Hi everyone, and welcome to today's webinar in partnership with Husky Technologies, hosted by Packaging Europe. Today we'll explore how innovative caps and closures can enable adaptable and cost-effective manufacturing of lightweight designs. My name is Emma Liggins. I'm a journalist at Packaging Europe. Sorry for anyone who was expecting Elizabeth. There have been some last-minute technical difficulties today, so you have me instead. For those of you who are unfamiliar with Packaging Europe, we are the leading intelligence resource for packaging professionals around the world. Via our magazine and website, we are, as well as online and in-person events such as the Sustainable Packaging Summit, we deliver daily news content, authoritative comment and analysis, case studies, and high-profile interviews with leading industry players and enable communication across the packaging value chain. For today's webinar, we are joined by Albert Mitjens, who is Production Manager, Closures Applications at Husky Technologies. Lightweighting continues to be a major trend globally, and premium brands are increasingly opting for small diameter neck finishes and closures, once commonly associated with budget brands. Innovative caps and closures are at the forefront of this trend and have fostered a tooling evolution that enables adaptable, cost-effective manufacturing of lightweight designs. Today, we will find out more about why global beverage brands are switching closures, specific design best practices, and the significant merits of a monomaterial package solution. Before I hand over to Albert, who, by the way, is product manager, not production manager, just a bit of housekeeping. There are 15 minutes at the end of this webinar reserved for a Q&A. Using the chat facility, please direct message us with your questions, and we can put them to our presenters at the end of the session. You can do this throughout the entire webinar, and we will endeavour to get back to as many of your questions as possible. For any technical questions, please select the support button, which you will see on the left-hand side of the screen. We also have a survey for you. To fill it in, just click on Post-Webinar Survey at the bottom of the screen. With that, I'd like to hand over to Albert for the presentation.
Thank you very much, Emma. Thank you very much as well, Packaging Europe, to let me here present today. And as well, thank you very much to everyone in the audience to have the privilege of your time. And I hope you find it really interesting. So I this presentation in 5 main topics. So it's to make it a little bit easy in terms of flowing of the presentation, but mostly I will talk about market trends, more focused on the water. Then I will talk about lightweighting methodology, what Husky has been done since the last years in this topic. Then we will talk about a little bit of tethering. It's really being a really common use, topic those days, especially for the new law that it's coming in less than 5 days. So it's as well a really good topic that we will spend a little bit of time how we have developed this kind of closures here in Husky. And then we'll talk a little bit about our tooling, our robust productive tooling, which will be a little bit more, maybe not too much in detail, but to give you an idea how this is, how we have worked on this since the last years. And the last but not the least, I will talk about the PET closure and the monomaterial dispensing systems. That it's one of the most exciting projects that we are working on. And yeah, I hope you will find it really interesting. So let's talk about a little bit of PET packaging and the forecast that we have for the next 4 years. Okay, so if we talk about water, there is a growth more or less produced about the 3.3% and a global 3.5% in the overall PET packaging. So water is around 3%. On the CSD, it's around 2.6%. It's a little bit less, but it's a steady stream, going upwards as well. And then we have the juices and soft drink and teas. This, as you see, the growth is even higher for many reasons, right? Because mostly this is led by Asia, where we have the most population in the world. And actually, these are as well areas that they are drinking this kind of products more than other areas of the world, right? Like teas, like dairy products, like fermented milks. So they are really, really popular there. Okay. There is as well 3 main consumption trends globally. So we can see mostly areas like North America and Africa and Asia, which the water is still strong there, right? For several reasons, right? Some different reasons, I will say. Then we have the CSD main drivers, which is still the Latin America and Europe, which mainly it's because it's something more cultural, right? The soda drinks are really popular there. And then, as I said before, the juices and the soft drinks and teas are really popular and really let's say, important in these areas of Asia and the rest of the world. Okay, so if we talk about water overall in the world, this 3%, where it comes from, right? So America, Latin America, the growing is not so strong. I mean, it is, of course, 2% is already a lot, but what is really driving the growth is Africa and Asia, okay? So again, these areas are where we have more population of the world, and as well, it's areas that drinking water, it's not really, sometimes easy to achieve. That's why PET is growing there, to provide them some safe way to bring water everywhere on really in remote areas of these countries. Okay, Europe and Oceania, it's as well growing in a different way, but as well some really strong in some areas. Okay, so we see three primary water segments. So we see, like we call, the premium packaging, which they are really, focused on aesthetics, on how nice is the product, and that it's really coming from your eyes, that it's something really nice, really, let's say, we have a really nice drinking experience as well. And they don't really look at, let's say, really focused on reducing drastically the weight, right? So they are still using old neck finishes like 2925 extra tall, the old 3025, or still the PCO 1810 or 1881 to give this premium brand and this premium looking. Then we have what we call the mainstream. Mainstream is more, let's say, the standard or more accessible waters all over the world, right? They are sold sometimes individual or in small cases, right? And as well, they are sometimes driven by special waters like that high alkalinity or things like this, that they give you something else than water, the same as the premium products, I would like to say. Okay, and then we have what we call the value or the bulk formats, that they are really considering the let's say the price basically, and they are easy to be bought on big cages or let's say big quantity of samples, to easily pack them, to easily transport them, and so on, right? And usually these ones are used basically more in the really lightweighted necks, like the new 2522 or the 2622. Okay, so we think that the sustainability is really driving the real change. This kind of necks, like the 2522, for example, in this case, was more, let's say, expanded in America at the beginning, but then slowly went all over the places of the world, right? In Europe was a little bit reticent to absorb it or to really go to this direction, because it was seen as well a package a little bit jeopardizing, let's say, the drinking experience. However, at the end, it became quite a subjective topic at the end. So rapidly, they saw really the let's say the benefit, and they started to expand in all other areas of the world. Okay, so the main drivers were what we already more or less explained, is like the weight savings for sure, the cost savings, faster productivity, and obviously advertisements of social media and all of this. When we see these kind of really light packages, it gives you as well really strong sustainability message. Okay, big brands were somehow jumping to this neck to really see that there was all of these benefits. So if we talk about the industry standards on the water finish, we come from a really far away, right? 30 years ago, we had our 3025 high. It was a really, let's say, expanded neck finish. And we can see that after 20 years, approximately, is when they started to think about how we can reduce a little bit further the weight to make it more productive, cost productive, and so on. So we went from a dispensing system with around 5.5 grams to already something which was 3.5 grams. So we are almost reduced 2 grams at this stage. In 2012, we went even further, and we started to introduce the 2622, the 3-start as well, or the Jimmy 3028 standard neck, which we really break the barrier of 2 grams on the bottle, right? That was as well a big step, actually. And this, in combination with the closure, was already a big achievement, because we started to see closures close to 1 gram only. Then there was a further iteration that this really break all the rules that we had at that moment for water dispensing systems, which we almost achieved a 1 gram neck finish weight, right? So this was a really big step, because here we started to see that the 50% of the closure, the closure and the neck, it was somehow balanced, right? So this was already something that was playing a big change. Meanwhile, of course, there was some ideas to, let's say, to compete against, to keep the same, let's say, drinking experience, or some to at least to keep something that was really working in Europe and Middle East, which was the 2925, and further reduce it a little bit more. But of course, this was still far away from the 2522, or it's still far away from the 2522 if people started to think to convert. Okay, now I will show you, and I will be more precise in these two guys, because I will explain you in terms of money what does it mean. So if we talk about the 2925 and the 2522, one can think about that, okay, we will maybe lose a little bit of grip, right? But in our case, for example, we have developed closures to absorb this, so to really keep the same grip that we have on the 2925, so we have the same height of the closure, or even more. That, of course, it will be compromising a little bit the weight, but however, it will still be really attractive. So we are only losing, let's say, something like, so we are losing around 1.6 grams of savings, okay? But if we go even further away, because the grip is not really a concern, we can go to 1.85 grams of savings. That means that if you think about overall, with 1.4 grams of PET savings and 0.45 grams of HDP savings, we can save, or we can have $227,000 of savings, producing 100 million pieces. So I think it starts to be a number to take it in consideration for people that they are thinking to move or to make this conversion. Okay. Then, okay, sustainability, again, is driving the real change. And if we, let's say, rip these two necks, and let's say we compare one to the other, what is the benefits on both sides, and if we compare all of them, you will see that it's quite interesting. So if we think about the weight, there is no discussion. The 2522, it's lighter, so there is no discussion on these two, which one is the best. In terms of grip height, if we do what I already explained in the slide before, there will be no compromise, because we can keep the same grip height even with a really lighter neck finish. On diameter, unfortunately, the 2925 is bigger, so there is no discussion. The 2925 won this battle. On drinking experience, again, the 2925 is bigger, so it looks like it have a better drinking experience. However, again, this is something a little bit subjective, because we have seen that some others are as well doing the same, and they are not really focusing in these kind of things. In terms of productivity, the cycle time here on the 2522, there is no discussion. It's really faster to produce, so it's winning more in this side. In terms of performance, they are exactly the same. So there is no big benefit to go to the one or to the other, because they are almost the same concepts of restarts and so on. In terms of tethered capability, no discussion. Both are the same, so both can be perfectly fine for both. In terms of cost savings, definitely the 2522 is a little bit better, highest throughput, higher productivity. And in terms of sustainability, there is no discussion. So 2532, it's a little bit better. If we think about on our portfolio, how we are adapted in the 2522 at Husky, we have, let's say, we are doubled in the closures, right? So we have what we call the standard 2522, which we have an incredible weight of 0.7 only, with a grip of 6.4 millimeters. And you can imagine how the productivity can be in this kind of really lightweight closures. We have the same for the ones that I explained, that they prefer to have a better grip. So we have a taller version, a little bit heavier, definitely. But the grip is giving to you, it's around 0.2 millimeters, which apparently it's not a lot, but maybe you can feel it in the hand when you do this test. We have as well for both designs the tethered capability, obviously for the new regulation. And the good thing here is that as well we have what we call the shell locking capability, that you can open the closure till 180 degrees, which is giving you better comfort and a better opening experience. So now we will go to the lightweighting methodology, how we are using that or how we are approaching that in Husky, and you will see that it's quite interesting. So first of all, why we lightweight, right? So the first topic is the resin usage. It's pretty straightforward, right? Manufacturing, less energy. We reduce the path weight, so less energy to produce, less energy to transport. The second thing is the productivity. So you gain cycle time, so it goes a little bit faster in terms of production. And the third point is the cost, right? So less raw material cost, lower pipe energy cost, and lower transportation cost as well. So one of the arguments as well, quite interesting, is that that the packaging differentiation can be as well something to pay attention in terms of lightweighting, and can enable a little bit of movement to go to a lighter neck that can provide you let's say, a different view in your packaging. And the second, let's say, argument that we think is quite important is as well the legislation, right? So if you are coming from let's say, from a lightweighting design, a little bit more advanced, will be better to be fulfilling the new legislation rules or whatever, that coming, for example, from a really old neck like 1810 or something like this, that perhaps there is not too much, in case tethered is mandatory, maybe there is not too much possibilities, right? So closure development methodology at Husky, we have two streams basically. So we have our virtual environment, where we first of all we define our closure type that we want to have. So first we start to think about which shell would you like to have, which TEV, which tamper evident band, which finish will be the final desired one. So once this is really framed and defined, we go to the next step, which is basically the concepting. So the design of the closure in CAD, we start to think about, okay, what is the purpose, which kind of top panel, which kind of thread, which kind of tamper evident band, and so, okay? When the CAD design is finished, we can have several concepts, for example. So we go what we call the FEA. So it's really a production simulation, what we can, let's say, expect in terms of virtually, depending on the designs that we have defined, okay? So the FEA works very well because it can tell you, or it can show you weaknesses on some areas like injection, like ejection, like, for example, shrinkage. And keep in mind that today the closures are not like 20 years ago, where most of them, they were perfectly symmetrical, perfectly designed in a way that it was pretty straightforward. Today we have something more in a way that is, we have the tethered, for example, that perhaps when we have the injection process and so on, we can see that there are some issues during the filling. So this is helping incredibly a lot to pretty define what to do, what to reinforce, or whatever, okay? And then the last thing that we do is as well what we call the mechanical FEA, which we can simulate exactly the capping process, the performance test, and everything which is related to the mechanical properties of the resin, right? This, I must say that it's powerful when you have really good data behind, right? So you need to have all these resins properly characterized, and that's why we are proud to say that we have a really nice lab with a lot of resins characterized, and this is helping incredibly us to really know upfront if there will be any issue during the performance of the closure. At the same time, it's pretty interesting because it can give you as well an idea how for example, if you have two designs and you don't know exactly which one to go for, it can give you an idea to make at least a correlative comparison to say, okay, which one of these two is better. Even you are not really sure if your model is perfectly fine, right? So this kind of tools helps you a lot to speed up on the market, and when we start to cut steel, that we are sure what we are going to do. Okay. So the second stream is a physical environment. So once we are sure what to target, what to do, and so on, we design our mold, our pilot mold with the stacks. And in our campus in Luxembourg, we are able to inject the closures. We optimize the process to make it as good as possible. And then we can go to the next phase, which is the closure inspection. So we have optical devices, prop devices to really see if the closure is per the design intent. So what we have already seen on the virtual environment, and again to see if we need any improvement on the processing or on any other side. Okay. The next step is the lab performance test. So actually the core of the design intent of the closure, right? So we test in our physical lab here in Luxembourg or in Shanghai or as well in Canada that we have the latest, greatest equipment to test packaging systems. So everything related to closures, we can test, like sealing tests, like torque tests, like impact tests, like a stress cracking test, all these kind of things, we can do it. And at the end, we do this empirical experience test that we can show exactly what the closure is capable of. So once all of this is done, we go let's say to the real life, right? So we go to a customer line, or we go as well to a small scale line that we have in Toronto, that we can run some closures really high speed, like in a real line, and we see how the closures are performing, right? So making all of this effort with all of this process, we are sure that somehow we will be successful at the end. Okay, so another important topic is in terms of lightweighting is how we can reduce weight on the closure to don't lose performance on it, right? So what we usually do is we brief the closure in several areas, like you see in the screen. So for those that are not really familiar, we talk about the sealing system, which is the outer seal, the plug seal. Then we have the top panel, which is the thickness of the closure from the top. Then we have the sidewall, the nulls. What the nulls in fact are the ribs, or let's say the area which the closure has been, let's say it's transmitting the mechanical force of the chuck to a torque on the closure, and that's why you have these ribs to grip. The tamper evident band and the cams or the nips, it's the same, right? So on some areas you will think, okay, we can reduce a little bit here, a little bit there, a little bit however, but for sure there is an impact on the places that you would like to remove the material. So what is really important is that where you want to remove the material is safe and it's not creating any further issue. For example, man can think that, okay, we will make the closure a little bit smaller. Okay, maybe you don't see any issue on the design perspective, but at the end, maybe this will be a really big challenge for the filler, right? Because maybe the closure is too small or it's too big, and it can jam. It can create issues in upstream, in downstream. So all of these kind of things needed to really take it in consideration once you are sure where to remove the material. Doing it in this way, as we have the virtual model and so on, we can really make sure what to target, how to target, and be successful. So it means that you will be more confident at the end, and you will not need to repeat too many iterations to be successful. Okay, that means that, of course, the speed to the market can be faster using this approach than others. So another interesting thing is that now that we have the tethering, the thing is that we started as well to think about adding, for example, the tethered functionality on the closure. One can think that maybe you are adding more weight, right? Because you need a leash, you need some features there, right? So if you need some feature, everybody will think, okay, this means more material, means more weight. However, doing all of this exercise, we find it out that some areas can be either further optimized for the tethering, right? So it means that what was thinking or what was not maybe playing a big role in the past, now with the tether, it's a little bit different. And this allows you to make something a little bit different, right? So here in this case, it's just an example, but we managed to reduce 0.1 grams on the closure, even adding the tethered functionality. Okay, so now we will talk a little bit about our portfolio. It's meant to be dynamic because we add and remove some closures depending on the needs and what we see in the market trends, right? So that's why we like to show it that sometimes some closures are disappearing, some of them are added in a short notice, but that's the way how the market goes as well, because it's really dynamic and we like it to do it in this way. So if we talk about water, we have closures for the 2522, so the GME 3039 for two, let's say you see here two, the standard one and the extra tall for the story about the gripping height. Then we have the 2622, the GME 3028 with around 1 gram. We have the PCO 1881, 2925. We have three different kinds of 2925, what we call the standard one, the tall one, and the extra tall one. We have it like this because we have seen a lot of interest for this kind of some kind of customers that they like to have a really big grip, small grip or the standard grip, right? As well, we still keep our old 3025, which is still being being popular in all areas of the world. That we believe it's fair to keep it. On CSD, we have closures for 22 millimeters till the 1810. So the 22 millimeters is mainly used in India. Sorry, only in India. Then we have the GME 3037, the GME 3037 as well with a different technology, what we call the slit fold. We have as well the GME 3040 with different kind of grips and different kind of null profiles. We have as well closures for the GME 3041, which was, let's say, a neck that was born at the same time that the GME 3040 or there, which is slightly different. We have as well closures for the PCO 1881. And as well, we still keep the old PCO 1810. For just juices and soft drinks and teas, we have closures for the GME 3036, which is the 32 millimeter closure neck, and as well the GME 3025, which is the standard 38 millimeter closure. Okay. On these two, I will say that the 32 millimeters we believe that it will be the substitute in the future for the 38 because it's a really well balanced neck. And of course, we pushed a lot to make a lot of developments on this neck for this particular reason. So all our closures, they have no license fee, so they are we don't need to pay royalties. They are tested against the SETI, the most aggressive standards in the industry, even further away with other big brands that they are using to test the closures to make it as robust as possible. And of course, we are on demand. Sometimes we have to achieve a particular performance criteria. So we are always trying to accommodate what is the real need at the end. And as you might see and you might realize is that we try to be as much as competitive in terms of weights. So now we are going to the third chapter. We will talk about a little bit of tethering. Okay. So tethering in 5 days, the 1st of July, will become the new SUP, beverage containers with volumes smaller than 3 liters, will require that the closure stays on the neck. So I'm pretty sure that you have we have seen a lot of advertisements, a lot of social media, sometimes as well a little bit funny about all of these closures, right? It started to be a little bit complicated at the beginning because consumers, they did not know exactly how to deal with these closures, right? So they started to rip the closure from the neck and so on. But then when the people started to realize that this was done in purpose, you will see, at least personally, I think that people start to understand how to use these kind of closures, how to lock them on the neck and so on. And this is the future, at least in Europe, and is what we need to deal with. These kind of proposals were as well integrated in other areas of the world. Actually, I think California and the United States, it was a little bit even prior to the European legislation, but then at a certain point of time, it was a little bit more put in, I would say, in pause. I don't know exactly the situation right now, but for sure, this will come again, and it will be in the discussions in the few years, and especially when Europe has something implemented, all other areas of the world as well, they see what they do usually, and at least they discuss how if they needed to somehow proceed with the same approach. Obviously, that is not really the only way, right? There are other ways, and that's why it's good to have different proposals and different ways to see how we can really improve the sustainability of the PET and the closures, that to make it as less as harmful as possible for the environment. So TEDx at the end is a global opportunity as well to promote sustainability message, as I already said, differentiation for sure, and something as well to explain, right? So when something is new, it remains somehow in the brains of the people, right? Say, look at this, what they have done, why it's like this, why it's like that. So at the end, people is talking about this. So it gives you a different way, I will not say for free, but to talk about this big opportunity. At Husky, we have two kinds of tethered closures, what we call the 160 degrees with the shell locking, right? Which mainly the closure is, let's say we have a main arm or leashes that we call, that they are attached the closure to the neck. And then the support ledge, so this ring underneath, is really limiting the opening of the closure, right? That's why we have usually 160 degrees of opening. However, we have as well our 180, which we believe it's a little bit better because it gives you a little bit better opening of the closure up to 180 degrees. So the concept is a little bit different, but the principle is more or less the same, right? So you have the leashes that they are expanded a little bit more, and they are and with the hook you can somehow clamp it either in the support ledge or here in the flat. Okay. The only thing here is that depending on the bottle shape, that can be a little bit challenging because there could be an interaction between the shell and the bottle. So usually the bottles are not really really special in this area, but I have seen sometimes that this could be, or at least needs to be somehow thinking it a little bit more in detail. Okay, so again, we avoid the interference of the closure when you drink or you pour the water. It's more intuitive, so you can really see when the closure is clamping. So you hear really the click of the closure, which is really nice and it's really evident, I would say. And then again, you have to differentiate a little bit more from others. Okay. So sustainability differentiation. Okay, people will say, okay, if it's not really mandatory, is it really happening in other areas that the legislation is still not there? And the answer is yes, quite a lot. We have as well a lot of projects outside of Europe that they would like to give this approach of the new of the new brands and so on, to give this differentiation profile. Okay. So our dynamic our portfolio in terms of tether is more or less the same as I showed you before. So same kind of neck finishes. Okay, we have from the Jimmy 3049 we have 180 degrees, as I explained you before, in both kind of closures. On the 2622 we have as well the 180 profile, and then on the snap closures, these in fact they are a little bit more interesting because it can open a little bit more. And these are the famous closures that they don't have a thread, right? So at the beginning was not really, maybe people were thinking, oh, a closure without a thread, it's going to work and so on, but they are there, right? So they are in the market since some years and they are working pretty nice too. We have as well solutions for the standard 2925, as I said you before, with both versions, the tall, the extra tall, and as well for the for the 3025. Which here we have the two possibilities. We have the 160 locking and the 180 locking. On CSD, same story. Jimmy 3037, we have only the possibility of opening of 180. We prioritize this one because of the, let's say, the shortest position of the neck. And at the same time, I must say here that we are a little bit more limited in terms of the support ledge, because this neck has some variance, and the diameter sometimes can make that the closure is working better or not. So it's better to take a deep look before we proceed on this one, on which kind of bottle or neck will go at the end. On the GME 3040, we have solutions for both. So we have the 160, the 180, different null profiles, different thread profiles, and light weighting, a little bit more robust, because as you may know, some areas of the world are more demanding in terms of carbonation, for example. So we have a really big brand of possibilities, from starting from 1.7 grams till around 2.15 grams. 1.8 grams, 85 grams. Okay. On 1881, same story. We have more robust closures for the same topic, and they can be opened at 160 degrees or 180 degrees. On juices and soft drinks and teas, same thing. So we have solutions at 180 degrees for the GME 3025, as well on 160. And on the 2 stars, the GME 3029, we have at the moment only available the 160. Okay, again, all the closures have been tested. This is important to mention as well, that has been tested according to the EU directive, of course, but at the same time, we went a little bit one step further, because as you may know, the directive of Europe, it's mentioning that you need to be able to open the closure 15 times, okay, without breaking the closure. And the pull force to remove the closure from the neck, it's a minimum of 25 newtons. So here we have done this test even in worse conditions, like for example in cold conditions where the material is more brittle and maybe can have more challenges. So we try to overcome all possible solutions to make the closure as robust as possible. Okay. Same thing, we have tested it and against the higher, let's say, industry standards, and a little bit further away. So we went to the most demanding closure protocols to make sure that all of these closures are robust enough. And again, we think that we are leading as well the weight in terms of tether, because this is as well really important. Okay, now I will go to the 4th chapter, which is related more according to the mold concept that you have. You will see a small animation now. Hope you see it. Sorry. So the hot runner has been designed in a way that the melt challenge is balancing the flow to have the minimal pressure drop, and of course too easy to change the color, right? That we can really, let's say, quickly change the color. To minimize the deflection, we as well contour the plane geometry for optimal drop and to maximize the bolting locations. We have as well a really integrated pillars to increase, let's say, on the ejector plate to increase the robustness of the mold to avoid the deflection. Same in the manifold plate. And yeah, to have a really nice loading path to be supported end to end. Yeah, we are proud as well to say that we have a really high productivity systems right now. So we have already some molds in the field with 128 cavities, 8 columns and 16 rows, that they are running really fast, close to 2 seconds, and they are producing samples 2,500 closures per minute, which is really, really high throughput. And yeah, you can imagine how many closures per year you can produce with these big beasts. Okay, now we are going to talk about the new mono-material dispensing system, right? As I said before, this is one of the most exciting projects that we are working on. And I wanted to say that, first of all, this is really a truly 100% circular packaging, okay? So we manufacture either with raw material or recycled materials. we consume till it's reaching the limit of the life. We recycle on the same stream, and we repeat the loop infinite times. So this closure, let's say this new thinking of the PET closure was done in a step-by-step approach development. Okay, we started first of all with the NCB, non-pressurized, so the still water, because was one of the, let's say, not maybe the less demanding performance, but at the end we think that it's a good way to start the project on, right? So some years ago we were not even able to inject the closures, because obviously at that time we did not think about, we had more on our heads the way how to design the closures in HDP. So this was really a big challenge to overcome, and since last 2 years we are managing to inject and as well eject, right? So the same thing here. Ejecting a PET closure is not ejecting an HDP closure, right? You should have a special way to think about how to design and to have the right tooling to make the things in a way that is really possible. On blue here, what you can see is purely performance, right? So the performance is a big topic as well, because you can have really a nice closure, really perfectly ejected, but it needs to go through the PET bottle, right? It's the same material. So, and this is where the challenge starts. What we say is that, okay, we can make it seal, but we need to open it. So this is actually what we are working on to really resolve this contradiction. We have been done really big steps here. And actually, this is the key, what we have seen on the development of this project. On strip torque, this is something not really important, because the stiffness of the PET is already giving you what you need to achieve. So actually, this is already good to think about, because PET enables you different way to think about a lot of tests. In terms of these two tests, so the drop impact and the ball impact, they are somehow together, right? PET, somebody will think about that it's more brittle. It is indeed, and that's why we need to consider this in a more, let's say, I will say careful way in terms of all impact tests. So we need to make sure that it's strong enough to fulfill all the standards. And the last but not the least, and the one that it was the most challenging one, is you need to have a really a good tamper evidence, right? I will explain you more in details on the next slide. What does it mean? Okay, so what is really important is that on the PET, if you want to have a closure that comes out directly from the mold with the bridges already molded, and you wanted to cap it directly on the PET bottle, with this kind of material, it's really challenging, because you want to have the minimum interference during the capping, right? So the minimal stress under the bridges to make sure that once you're capping, the T-band is expanding properly and not breaking the bridges. And at the same time, what you want is to, when you open the closure, that the band stays underneath the support ledge to make sure that the opening is smooth and nice, right? So this contradiction is really the challenge here. So on the PET material, it's really difficult to find a narrow window, or I would say a sweet spot, to make this happen, okay? That's why we developed a new device, which is a prototype, what we call the T-forming device, which is it's a device that it's basically think to be installed after the capping line, which what is doing here inside is that adding a heat stream to the tamper evident band to shrink the tamper evident band in the pilfer bit of the closure and create the tamper evident, okay? So what is really nice on this kind of tamper evident band is that you have a really audible click when you break the bridges, right? So it's really evident when somebody is opening a closure made on PET. You can sometimes in the same room, if somebody is opening the bottle far away, you can already hear the noise that it's doing, because it's really audible. So it's really cool for that. There is as well a really nice tactical response. So you really feel that the closure has been opened. There is a visual cue. So there is a kind of pan drop. And as well, it's really difficult to make it, to really tamper the closure in a way to spoil the content. So that's why all of these things, we believe it gives you a really nice opening experience on this side. So rigidity as well is unlocking as well new lightweighting opportunities. What does it mean that? Okay, somebody will think that the PET is more dense product, right? Indeed, if we mold the closure on HDP or if we mold it in PET, the PET will be always heavier. However, PET, due to the properties of the PET, it gives you some other things that on HDP maybe you are not even considering, right? So here, for example, we can somehow optimize the dispensing system, let's say changing a little bit the neck or the preform in a way to compensate this density difference and to be, let's say, close to what we have today. So what does it mean? It means that for sure it gives you a different way to think about, right? How to design closures in these kind of materials. But we are just at the beginning, right? So we started with different kind of neck finish now, and we are experiencing that we might have other possibilities, and the door will be open to further developments to other necks to really, let's say, enhance all of these monomaterial dispensing systems. Okay. What else is giving you the PET closure? So it gives you definitely a packaging differentiation, right? The good thing of the PET is that really transparent. You can see through. You can do. For example, it can give you a better view in a way that you can differentiate and so on. This glass thing, it's really nice, right? And at the same time, you can engrave logos, you can engrave QR codes, and if you want, but maybe it's not the best idea is as well, you can give it a little bit of color, but at the end, yeah, maybe it's not really think about this because then you will use the recyclability stream and you are jeopardizing all these nice, let's say, good things about the monomaterial packaging. Okay, so just to recap a little bit more, sustainability message is really strong on the PET closure. The differentiation, premiumization, it's something that we will see more and more now coming in the future. And definitely something else that we can explain and we can somehow show it in the social media and all of these places to really tell that, yeah, there are ways to make the things a little bit more sustainable. And we believe on the packaging industry, this can have a really big impact on all of this. Okay, now a little bit of recap. We are Husky. We have 40 sales service locations, 9 distribution centers, 7 manufacturing locations. We are close to all the customers. We speak their languages. We have several places. We are pretty well distributed around the world, I will say. And yeah, just to recap, we sell systems, we sell tooling, hot runners, closure preform molds, medical. And in terms of service, we have something really interesting now, what we call the Advantage Plus Elite, that we can monitor all kinds of our machines remotely. Sometimes we can even know if a device is not working properly before the customer is even realizing it, because we can monitor it really on real time. And that's it for my side. I will pass it by again to Emma. I hope that you find it really interesting, and I'm glad to answer whatever question that comes in the future. Thank you very much.
Okay, great. Thank you very much for such an interesting presentation, Albert, and thank you to everyone watching for your attention so far. Now we're going to move to the Q&A section of the session. We've already had some great questions coming through, but please continue to send them if you have them. If we don't manage to get through all your questions, don't worry, the team will follow up with you after the session. So just to start with, do Husky's tools allow you to have a solution tethered and non-tethered with the same mold?
Yes, absolutely. This is something that maybe I should pay more focus on the presentation, but I can explain you quickly now. We have a technology, what we call the tethered ready. That means that the closure that we have right now, or if in the future a customer wanted to to have a tethered solution with a really small change, like what we called the sliders or the sliders swapping. We can mold a closure tether or a non-tether, right? It's a really simple step to change, and actually it can be done even without disassembling the mold.
Okay, great, thank you. So do you already see any advantages or disadvantages about the production process of PET closures in comparison to HDPE ones?
Definitely. I mean, there are some things that we needed to let's say the injection process was a little bit difficult to, as I was explaining at the beginning. 5 years ago, it was even not possible to inject PET in a closure mold because the injection pressure was higher. So we needed to overcome to a lot of milestones and challenges. However, for sure, as I was saying, I mean, we were learning by doing at the same time, right? So we were trying to find it out what we could overcome to make the PET flowing in a way that is maybe not the same as HDPE, obviously, but to be as close as possible to enhance, let's say, the same way of injection closures in HDPE. It's not done yet. I mean, we are still working on it, and we started to optimize it to make it as best as possible. But yeah, definitely. I mean, this was a really big topic, and it's still a big topic to talk about.
Thank you. So what is it about energy consumption with PET closures in comparison to HDPE closures? Can we use the cap mold in the preform injection machine?
Well, you mean if we need to change something else in terms of, I mean, if I understood it well, the question, I mean, the energy consumption, of course, I mean, the melting properties of the PET are not the same as the HDPE, obviously. But this, let's say, can be somehow a little bit modulated in a way that is not impacting so much this topic. Definitely, as I said, we are still learning, we are still optimizing the way how to do it. And definitely there will be some other concerns that will come in the future, and we'll take it from there.
Thank you. So how are you able to maintain weight neutrality while incorporating a hinge feature when it comes to these closures?
Yeah, it's what I was saying a little bit before. I mean, not all the time it's easy to make, let's say, the tethered implementation of the closure, and it's not really straightforward sometimes. The problem here is that you need to think about what you really can remove, right? So where are the areas of the closure that you can really remove the weight, and adding this tethered capability. Sometimes it's really straightforward, sometimes it's not. We have our patent hinge version. We are really happy with it because it works very well. But of course, sometimes we see challenges because you might think about that one neck to the other, it's not the same. Sometimes are a little bit longer, sometimes are a little bit shorter. We are thinking as well on the recapping possibilities of the closure, that it's easy, it's intuitive, it's not really, you don't want to see people, playing with the closures to try to cap it again. So we try to find the smartest ways to do it. This, for sure, it gives you as well the possibility to enlarge the leashes, make your notch a little bit longer, or perhaps thinking something completely different, right? So at the end, tethering, it's challenging, but at the same time, it's as well an opportunity to think about a lot of things that in the past you were not really having on the table, right? So this will be definitely moving even further at the same time, because so far we have seen in the last 4 years that especially in the European market, we have seen some tethered closures that they are not there anymore. So they are already being optimized because they have seen that after 1 year in the market, they said, okay, maybe this is not the best approach. Let's do it in a different way. And the other way around, you have seen already some closures that they are since day zero on the market, and they are working very well. So in our case, what we have seen is making a lot of consumer tests internally at Husky to see, okay, how do you see that? Is it okay doing it in this way? We should go it in the other way. And at the end, at the same time, it's a little bit subjective. So what I like, maybe the other ones will not like. So you need to, let's say, to see it everything in a conclusive way, that there is not always one solution.
Thank you. That was a really thoughtful answer. So will there be restrictions on colors when it comes to this solution?
You mean on the PET closure? On the
Yes.
monoaccept? Okay, so again here, so if we think about the PET closures and the overall, let's say, message at the end, right? So why we are doing a PET closure, right? So we want to emphasize the sustainability approach, right? So adding material or adding another material on the stream, it can create some noise, right? Or it will not give you maybe the best, or the same way to see the things, right? Some others will think, okay, we are not really for the sustainability here, so why not? You can colorize the closures as you want, and in fact, they are looking really nice because you have this transparency effect with let's say small colored closures, and as well, it gives you really a brand image. It is really powerful. So I will say, yes, it's possible, but maybe it's not really in line with a monomaterial sustainability message.
Thank you. So somebody wants to know whether the PET cap is currently available or whether it's still undergoing trials.
Yeah, so what we are on right now on the PET closure, we are starting to let's say to reach some early adapters. We are working on it, and obviously there is a lot of interest. We are really excited about it because there are a lot of customers that they are asking how we can do that, when we can do that. So now we are really in the stage of early adapters. So we will learn with them somehow how does it will go that, but definitely we are ready for that, right? So we are really excited to start some trials, real trials in lines and so on. So this will definitely be the next step.
Thank you. And we've probably got time for one or two more questions. Can the PET you're using to develop the PET closure be recycled in the same stream as bottles? And are there any additives?
Yeah, definitely. This is what we have already experienced, and we already working on it precisely for this topic. Our PET or a raw PET can be gone to the same way, and they are doing some studies still today and so on. But definitely, this is what we want. This is one of the most advantages that we see, and we will definitely work for that.
Great, thank you. So we'll probably close out with this one. What is it about the energy consumption when it comes to PET closures when compared to common HDPE closures?
So yeah, it's what I said a little bit before. So right now we are not really sure about or what we have experienced. So we are starting to make some models and to compare, because the good thing is that we have let's say a pilot mold machine that we are using currently HDPE, and now we are using the same thing on the PET. So we can take a lot of information. We are, let's say, collecting data in this sense to really make sure what will be this impact of temperature, what will be other things that may come, right? So for us right now, it's not really a big topic because we know and we are confident that we will find a way to make it attractive as well for energy consumption. But yeah, in fact, at the end, if you have a similar weight but on HDPE and the same throughput and so on, there will be a way to manage all of this in a way that it's attractive for both sides.
Okay, great, thank you. Unfortunately, that's all of the time we have for questions today. But as we said, if any questions remain, I'm aware that there's some in the chat that we haven't gotten around to yet. Those will be answered after the webinar. So thank you for everyone for joining us. This webinar will be available on demand within the next few days. You'll be sent a link to access it in case you want to recap on anything you've seen in today's session. We hope you've all enjoyed. Before you leave, please do let us know what you thought by clicking on the post-webinar survey link at the bottom of the screen. And that just leaves me to thank our speaker, Albert Mitjens, and thank you everybody for watching. Thank you very much.